Okay. Is this? Sorry. So this is now P9, and it's considered another review section in the book. And what's on in here is it's all this inequality stuff, and then we're also going to add in absolute values with the inequalities. All right. So first off, we need to be able to describe the solutions. Okay. And we use set builder notation along with number lines. Okay. And first is just translating from the interval notation to set notation and to the number line and back and forth, right? So, for example, and this may or may not be number 1 in the book anymore. They always change the editions. Let's say we have the interval from 1 to 6. Okay? So first off, parentheses means you don't include the endpoint. Endpoint not included. A bracket means you do include the endpoint. Endpoint included. So this interval notation means that, and let's go ahead and put it on the number line, right? Maybe that'll help. So I'll just pick some numbers, 1, 6, 7. Right. So this interval means to include everything that's in between 1 and 6, certainly. And then on top of that, we include 6. Okay, so you put that bracket on the number line, but we don't include 1. So you use an open parentheses there. And your teacher may have said like closed dots for brackets. So if you'd rather do that, that's fine with me. And then open dots if you don't include it. But that's what we're dealing with when you see that interval notation. Set builder notation is the curly bracket stuff. Okay, and to do this, we're going to say it's a set. This symbol means the set of. Okay, and then we're going to write x, the set of all x's, and then this bar means such that. And then we're going to write an inequality in here, such that x is greater than 1 and less than or equal to 6. Okay. And that's it. So what the heck does it mean? It's the set of all, and then we had this x, and then this bar means such that, and then we had this inequality, x is greater than 1 and x is less than or equal to 6. Okay, let's try another. Here we have -5, and we're going to introduce the infinity symbol, right? So, for some reason there's something that keeps popping up on me. I don't know what it is. Hopefully it's not anything important. Okay, so anyways, negative infinity and positive infinity are kind of introduced in this problem. So on the number line, where are those? Let's put some numbers in here. Infinity is considered to be way to the right, okay? And then negative infinity is way to the left. So to say all numbers greater than or equal to -5 to infinity is basically that interval that I just shaded in there. And we put a bracket on -5 to indicate that it is included. Okay, so in set builder notation, it's a set of all x such that x is greater than -5, greater than or equal to, right? And that would be that. And clearly in the other direction, an example, let's say negative infinity to 3. So on the number line, let's put some numbers in there. And negative infinity means go in the other direction, right? So it's going to be not including 3, but everything less than 3. Set builder notation, it's a set of all x such that x is less than 3. Okay. Okay. When the intervals are kind of split up, so you have like everything less than 5 or everything greater than 7, we need some extra notation, and that will be these union or intersection symbols. So they look like horseshoes. Okay. So first, let's take a look at the intersection of two intervals. Oops, let me erase that. Okay, so let's say -4 to 0 intersected with -2 to 1. So the intersection just means you're taking all the elements that are in both sets, okay, that are in both intervals. And one way you can approach this is to kind of do a number line for each interval. It's kind of time consuming, but it gets the job done. Okay. I don't know why that thing keeps popping up, and it's highly upsetting to me. So the first interval, -4 to 0. Sorry. Lost my Camtasia thing. There it is.